Cool. Morning, everyone. All right, so I'm here to talk to you about design patterns and techniques, but I'm also doing a couple of other talks this morning, so I thought I might as well introduce myself because you're hearing a little bit from me. So a little bit about myself, if this is going to work. There we go. Okay. So I'm a Brit who lives in Australia. If I'm standing up here yawning, I'm sorry. It's nothing to do with you. It's the fact that I'm still pretty jet lagged. Flew in a couple of days ago. In Australia, I actually like getting outside. I like doing a sport called canyoning and get out into nature, and a little bit dangerous, a little bit of risk, but a lot of fun seeing places not many people get to see. And then you can't do that every week, every day. So I like indoor climbing, regular indoor climber. This is my favorite climbing gym. I've been in this space for some time. I've worked on cloud OSS projects for a number of large service providers. The logos are up there. I've been with Cisco about 6.5 years. The last 2 and a bit years doing NSO. I'm technically the APJC Services Delivery Technical Lead. It sounds nice, but really it means my manager delegates a lot of stuff that she doesn't want to do to me. So, it's got its benefits, but it's got its downsides. And one of the kind of things for me, a theme through the things I'm talking about today is I don't like duplication of effort. I'm lazy. I'm really lazy. I like to copy other people's work and tune it to what's required. I don't like to be the first person doing things every time. So if you are confused in this talk, don't worry. We all come from different perspectives, so don't worry. You're probably not going to catch everything. I'm not even sure I understand everything I'm talking about today. Do ask questions if you don't understand, but some of these things are maybe a little contentious. So if we can keep the discussion to the end, I'm going to try and get through as quickly as I can, and then we can have a discussion about anything that you disagree with, or think it might be more beneficial to talk about. And I'm going to try and keep my feet on the ground. You may have heard this term architecture astronaut, where you're up in outer space and not grounded in the realities of what actually happens. But if I do go up there, bring me back down. So quickly, I'm going to talk about what are design patterns. I'm going to then go through a few little techniques that hopefully you're all familiar with in NSO. And then we're going to introduce some design patterns and then have a quick chat about what's useful, how do we as a community move forwards and kind of get better at this sort of thing. Why design patterns? Well, it's human nature. Our brains love patterns, right? Our brains detect patterns all the time, and they're really helpful for us to understand things, right? It helps us shortcut things in our thinking and the way we work, and that's mostly a good thing. But sometimes it's a bad thing. But I like patterns. I like understanding things, drawing diagrams, and seeing the patterns. Design patterns specifically, they help us solve problems, right? And they help us break bigger problems into smaller problems that we can more easily communicate. They provide a language so we can all talk the same language. We're not confusing each other. I don't have to explain myself every time I want to talk about one of these things if we all understand what they are and we can talk about them. And I guess the biggest one is they help reduce that duplication of effort. So I come from a software development background, not a networking background, and I read this book many years ago, and it's Design Patterns, Elements of Reusable Object-Oriented Software. And it's called the Gang of Four book, four authors, And if you come from an object-oriented software background, you probably read it. If you haven't read it, you know about it. And when I came to NSO, I kind of started asking people, well, where are the patterns? Where are the design guidelines? Where are the things that someone working in object-oriented software for like 5 years, I just take for granted? And actually, I don't think as a community we've done a great job of pulling some of this together. And Carl Moberg and I were chatting about a year ago, and Carl said, well, Mark, you complain about this, but you're someone in a good position to do something about it. So that was kind of the seed that's led to this presentation. If you're interested in this stuff, I'd also suggest there's a book, a classic computer science book, Structure and Interpretation of Computer Programs. It's all about Lisp. It's a brilliant book if you're interested in learning more about programming. It's worth the time. So design patterns. You may be familiar with the factory pattern. So if I want an object of type car, I can go to the factory pattern and get it to create me an object of type car, whether that's a Volvo, a Ford, a Mazda, right? The factory pattern is a fairly well understood pattern. And one of the most famous ones that a lot of you has probably heard of is the model view controller. Right? So that's fairly well explained in that Gang of Four book. It's very well understood in the software development world. But there are a couple of other types of pattern that you may have heard of or maybe not. We have anti-patterns, right? Bad ways to do things, right? This is common pitfalls. People have seen this approach, they've done it, and it's been really bad. It hasn't worked out for them. And then a fun one is dark patterns, like ways to do bad things. So online retailers love using dark patterns to funnel you, to make you buy a thing you didn't really want to buy, and there's a lot of techniques. So I'm not going to talk about dark patterns. I'm going to talk about one or maybe two anti-patterns and a few design patterns. Now, before we get into the design patterns, I said I'd go quickly through some concepts. So I wanted to make a bit of a distinction between what is a design pattern and what's just a technique. Right? So for me, these are kind of techniques or concepts that we use when we're designing things. They're not a way of designing in their own right. So stacked services, right? Basically a service modifying another service. We have metadata or config data, lookup data. I don't know. Pretty much every project I've worked on, we've always ended up putting some data in the CDB that we reference in our templates or reference in our services, so that it's there and we can modify it and edit it, and we're not hard coding values in our code or in our templates. Pre and post mod callbacks. Hopefully most of you are aware, you do things outside of create. It's outside of fastmap, and that can be helpful for some of these patterns. Reactive fastmap, NSO's eventual consistency hack, and I mean that hack in a good way, as in it's a workaround. It's not a bad thing. Kickers, if you come from a database world, that's it's like a trigger, database trigger, CDB trigger. Actions, I like to think of actions like a stored procedure in a database. It's not quite, but it's very similar. Resource allocators, again, coming from the database world, you'd get ID allocators. So the resource allocation stuff you can do in NSO is like an ID allocator, but to that next level. Plans, again, database world, that's where I come from. It's kind of like a job status, a database job status. Nano services. Now this one, I don't know where the product team are at with nano services. It's been a feature in NSO for quite some time, but it's not really been heavily promoted. I guess it's still in experimental status. Yeah. It's definitely worth reading about. If you haven't heard of them, go find the section in the documentation and take a read. It might be a good fit for one of your problems. And then the scheduler, right? Basically, do something for me later at this time. So most of these techniques, I'd say, would get used to some greater or lesser extent in a larger NSO package. But I don't consider any of these as design patterns. They're just things that we do. So I'm going to start with one basic design pattern. Now, apologies for the way these are presented. I still haven't figured out a good way to talk through all of these. I don't want to read through the slides. I don't have time to do that. And I'm just going to go through about 6, I think it is, different patterns and hopefully spark a good discussion with everyone. So the first one is probably a common one, but it's interesting and it's worth talking about because mostly when people hear stacked services, they say, okay, I'm composing a service. It's the object-oriented view of composition. So I'm going to have a service that is composed of, it owns multiple pieces and it brings them all together into one thing. But almost the opposite of that is a specializing service. So we use stacked services, but instead of that parent service composing multiple services and pulling them together, it's actually a more specialized version of the lower level service. And so the example I've got on here is something we've done for a customer, their internet exchange peering. It's really for them just a specialized version of a layer 3 VPN, except it's always the same VRF. It's always the internet VRF. But the standards for, there's no OSPF, it's always BGP. The route policies are very standardized. You can't choose which route targets you want to import and export. It's iOS XR, the route policies are well defined, they've been tweaked, they've been tuned, the internet network engineers understand them. So instead of building that as a new service or building that into the layer 3 VPN service and kind of complicating the logic, embedding all the logic for internet peering as well as all of their extranet and enterprise services, we put that as a separate stacked service on top. So, the good side of that is we can have a fairly loosely typed child service, that lower level service, MPLS, and a very strictly typed service on top that conforms to all the rules about how do we do route policies, how do we name things, how do we put the interface descriptions. The bad side, though, is now we've got to keep these two separate services in sync. If they were in one package, no big deal, but now we have to keep them in sync. I think it's usable in many situations. If you ever get your hands on the vBranch function pack, they actually provide a really good example of this sort of stacked service approach. So the common service model in the vBranch package is very, very extensive. Hundreds, maybe definitely hundreds of parameters in there. But when you expose that to your consumers, you're probably going to have standardized. So there's a really nice example in that function pack of a specializing service. So that's a nice easy one to start with. So the next one is deploy flags. So this one, I think a lot of people probably use it or have thought about using it. So sometimes it's really desirable that you don't push the configs to the devices straight away. And you could do that easily with commit no networking. But commit no networking is then leaving your CDB in some sort of inconsistent state with the network. If someone comes along later, not knowing that you've done a commit no networking and modifies your service, it gets pushed to the network unless they know, oh, okay, this hasn't been pushed. It's just it's a state, and it's not easily discoverable in NSO that, hey, someone's modified this and they didn't want it pushed. So a deploy flag is just a simple way of saying, you know what, this service, I don't want to push it yet. Don't deploy this. It's stored in the CDB, but we'll push it when we change the flag. Now, that's very easy to implement. I mean, it's super easy to understand and explain to people. The downside is, you have to take care if you want to modify that service later. And if you want to do a deploy, like a stage change, this isn't going to work for you. This is really only for that create time. A deploy flag's only really going to work when you push that initial service. The example I've got here is something I've implemented on a project. We have an A and a Z end of a link. We want to push that link. And with the A end device is there, it's available. We can configure the interface, but the Z end is not going to be available either until we've configured the A end because it's in-band management, or until someone physically goes and plugs the cable. We don't want to make the change. So we use the deploy flag to just control that. And actually the scenario was when you have a ring and you are breaking the ring to connect a new device, we want to be able to push that change to NSO, but not push it to the devices until the guys at the other end of the phone during the change window, and the operator just has to say yes, deploy. They didn't have to enter anything. They don't have to be that skilled, but they can just say yes. The guy has unplugged the cables, plugged them in, and we hit the deploy flag. So I said, this doesn't work very well for modify, right? It's great for create. So the next thing you can use as a pattern is a shadow service. So that's where you'd keep your desired state as the main service that you expose to the rest of the world, but you keep a shadow service in the background that is the current state of the network. And you can then say at some point in the future, okay, push the desired state to the current state. And you're using stacked services kind of in here. An implementation detail though is you can actually have this shadow service as operational data, or you could hide it so that actually people don't see the fact that this is happening from the outside. They just push their desired state into your service, and they don't actually know that in the back end you're keeping a shadow copy, and that's the ones that you're actually putting into your templates. Pretty much any service could be a good example of where you could use this. It's actually, again, it is used in that vBranch function pack that I mentioned. The first one was that Specialising Services. So somewhere else in the vBranch function pack, they use this concept to manage their workflow. So vBranch function pack is doing some fairly complex service chains, and to just help them keep track of where it's at and what's going on, they use this inside. The pros are, now we're not managing out of sync stuff independently. We're not using deploy flags that are only there for create. We're not using commit no networking. We actually have a nice clear representation. This is what I want it to be. This is what it is today. And then you can either have an action or a flag, or even set up a schedule, put a date time field in your Yang module and say, push an entry into the scheduler. When this time comes around, push the desired state to the actual network. And yeah, I've been kicking around some ideas about taking this to kind of the next level and having a list of historic states of your service, because at the moment, rolling back a service, you're relying on NSO's commit ability. I'll come to you in a second. But right at the back, Jon, if you. Yeah. So you're relying on NSO's commit ability, but if you kept a list of historic, states of the service, that's helpful for you from a management perspective, but also gives you that rollback ability. Yeah.
Thank you. Have you considered any ideas around like a revision numbering system incorporated with this, so that you can do your stateful rollbacks and or your dating, or your identify specifically which phases or which, in your northbound system you design your templates for specific revisions and then apply those based on what you have in your CDB?
So you're talking about versioning the templates?
Yes.
Yeah.
And or versioning your forward rolling configuration commits.
Certainly, that's I think a lot of people have that challenge, right? Versioning, and maybe it's some combination of instead of having a deploy flag, you have a version flag, and then that tells you the version of the template to apply.
Yeah, that's similar to what I was trying to.
Yeah, I think you could probably combine that with this to very good effect. Yeah. Thanks.
I can just add a comment to it. Yeah,
Yeah.
I've seen this with a version number for the config used in many cases when it comes to the deep telecom space.
Yeah. Absolutely. Golden template versions 8, 9, 10, and 13 are in the network. 11 and 12 are gone. They were really bad, and we didn't like them. Yeah. Okay. Yeah. I mean, obviously, the downside of this shadow service concept is we're introducing more complexity to our service, and arguably, this could better be managed in a northbound system. I'd lean towards this is a good approach in a service myself, but at some point, there will be additional external dependencies involved, probably, especially if you with an order management system that are outside of control of NSO, and so it might make sense for you to push this northbound. All right, one of the more complicated ones. I was debating whether to include this one or not. So don't read the slide. Object orientation, right? There's two concepts that are commonly used in object-oriented design. One is composition. My service or my object has these other things underneath them, and I own them. I create them, I modify them, and I destroy them. So when my object or my service is deleted, all of those composite objects are also deleted, right? That's kind of ownership, that's composition. The other common concept is aggregation. So I, as an object or a service, I don't own the life cycle of these other things, but I do reference them. I do need to make changes to them. But when my object or service gets deleted, it doesn't delete those things. It may change the config a little bit. It may, deregister itself if we're a event loop and I'm related to that object over there. I've put an entry in the event loop, so when something happens, I get notified. But that's aggregation. Now, most of the times when people use stacked services, they're using composition model. Now, the aggregation model is useful, but typically in aggregation and object-oriented programming, the aggregating object keeps the reference to the aggregated object. So the parent object keeps the reference to the child object. But you can reverse that, reverse aggregation, where the parent puts a reference to itself in the child object. And that's actually quite a useful thing in NSO, because I have a child service, and let's say it has a list. Now, I don't want to create that service from my service, right? I just want to put an entry in that list, and that child service is going to then push some config to the network. And the classic example where we've seen this used is in policies. So someone has created a policy object, a policy service, and it's been pushed out consistently across multiple devices. And now I've got a service that consumes that policy. Rather than trying to create that policy if it doesn't exist, and using ref counts, I put a reference to myself, or I put some parameters into that policy service. And that's really good, because now if that policy changes, I go to the policy, I change that policy, and that will get pushed to the network. And my original service is not out of sync. So when you do parent-child, when you do stacked services, managing your synchronization between the parent and child becomes quite complicated sometimes, can be tricky to manage. So this kind of reverse aggregation helps solve that problem. So it helps you avoid some of these service sync issues. You can do something similar with metadata, and you can look up what should the policy be and use that to push it, but that's kind of hiding what's happening, whereas this makes it more explicit. But yeah, you need to be careful with this. Yeah, we've used this a few times now. It makes a lot of sense for those kind of policy objects. As I mentioned, gold shaping policy, it needs to be standard across all PEs. But when they want to tweak that policy, change some of the burst sizes, maybe change which fair weighting queuing or whatever type of queuing that quas moves to, they want to do it consistently across the network, independent of the services that you've deployed, which consume those quas policies. Okay, so that's probably the most complicated one I'm going to talk about. And this next one is kind of related to the previous presentation. So when you reconcile NSO services, right, if you've got 30,000 devices, 60,000 services in the network, sometimes you need to relax the restrictions, right? You've done your service design, the network owners say, look, policies should be named this, interface description should follow that. All of these things should be within these boundaries. But then when you go to reconcile, you find, 60,000 services, only 5,000 of them follow your standards. And no one's going to go and remediate 55,000 services. But also, they don't want you to relax the restrictions you put into the Yang model, because they want that to enforce good behavior going forwards. So we can use a reconcile flag and some other flags or overwrite values. So when this reconcile flag is set, we relax some of the restrictions. Right? And there's a few different ways we could do that in Yang. We can use when statements to exclude some of the more strict leaves and have when it's reconciled, don't have the strict name, have the relaxed name. We can put some of those things inside the templates, and optionally we can make that reconcile flag an operational value. Right, so if we make that an opper value, then only code is setting this to true. So when a user is in the CLI or the GUI, or they can't say this is a reconciled service because I want to break the rules when I provision my new service, because they can't see it, they can't set it. But in the reconcile code, the action, the methods that you're using, okay, you can set that because your code, you're reconciling, you're allowed to break the rules. Now, one of my customers, we've taken this maybe a little bit too far. They didn't want to reconcile anything in their network configuration, but they wanted it all to be managed by NSO. So we ended up introducing a lot of overwrite values. So the value according to the service should be XYZ, all capital letters, must start with a character. But actually in the network, we have a mix of cases. Some of them start with numbers. So we create an overwrite value. So the service is keyed with its correct name. But then we have an overwrite flag that basically says, okay, in the template, if the overwrite flag is set, you can use the bad value. And that it's good in some ways because it makes it very clear to the operators, where's all the bad stuff in my configs? Well, it's in all these overwrite flags. So you go through and you can just, delete the overwrite flag from that service, do the commit dry run, make sure that what's going to happen on the device is what's expected, and commit, right? That makes it easy for the network operator to progressively fix these issues over time. The downside is your templates and your package code gets really messy. The templates that we had started out as nice, classic, clean templates, and they've ended up a real mess because of all of these. When the reconcile flag is set, and there's an override value, do this. Otherwise, do that. And yeah, it promotes non-compliant configurations. It's kind of saying, yeah, your mess is okay. You don't fix it up. Realistically, NSO for a lot of our customers is a good opportunity to reset, to make the investment to clean up their configs. Cool. So that's a few examples of what we can do. What not to do. So I'll put my hand up and say this next one I've done. We did this, and that's stacked services for everything. If there's a little bit of a configlet, if there's a need for a new template, put it in a new stacked service. That would be reusable, right? It's amazing. We can reuse all of these little services wherever we like. We get maximum reuse out of what we've done. That's nice in theory. Then you actually start implementing this, and you start finding that actually, there's a lot of independency in the configurations in the devices. So when I want to check, let's say I'm configuring some route policies, and I've got a little service for route policy, and I want to check for some prefix sets. I can't check that the prefix set exists on the device config. I need to check that it exists in my prefix set child service. And so when you start doing this, you very, very quickly end up in a pretty horrible place, because turns out the people who write the CLI in Cisco or whoever have already done a pretty good job of abstracting device configuration. There's a lot of interdependencies between all of these different pieces of config. So all I'm doing is starting to replicate the dependencies that are already in Yang. They're already there. So, is there value in doing this? Well, yes, there is definitely value in having some child services with stacked services. The really big kind of pieces, it makes sense, but not for everything. So, it's very tempting for me as an object-oriented programmer coming to NSO. I thought, this is the way. Everything's an object. Every object is a service. The other one is all the mapping code that you have to write between parent and child. You end up replicating device config, and you may as well not spend your effort there.
Another key litmus test, interdependency. Primary driver for why you would choose one approach over the other. So is that the key litmus test?
Yeah.
Interdependency.
So when we kind of looked at this and said, well, what have we done wrong here, right? This isn't working for us. We kind of rolled back and started saying, well, look, those three pieces are very clearly interdependent. They should fit within one service. This piece over here, it's not dependent on anything. Maybe it makes sense as a dedicated child service, but actually there's nothing in this piece anymore that's kind of standard. That we're not enforcing any standards. It's nothing special. So we may as well just put this back in the parent service.
Yeah.
And what we discovered really is this one down here, right? It's better to use good groupings in your Yang, write good templates, and then someone who comes and looks at your service saying, I need to reuse this, just say, okay, the grouping's already there. The grouping in Yang is reusable. I can now use this in my service. And that template, I just copy paste it because I'm using the same Yang. It's the same XPath. Now you could argue it's at that point you make the decision whether it should be a stacked service or not.
Because the temptation is always there, right? To break it down even further.
Yeah.
All right, thank you.
So I think actually Jan and I exchanged a little bit on the developer hub about stacked services for performance. I think it was you that responded to my question?
May well have been, yes.
Yeah. So I mean, there's good reasons to do stacked services, and then there are not so good reasons. And there are some good ones like performance. So stacked services can give you a good performance improvement if you have huge configs. I can go into more detail on this. I've got some backup slides, but
Maybe we should try some of that discussion, see
yes,
if people pick it up.
yeah. Yeah, so stack service for everything. Anti-pattern. One or two more. So this one, originally this was a pattern, but so workflow in NSO. I think everyone who's worked on any large service package with NSO has ended up starting to implement some sort of workflow inside their package. And you kind of have a couple of options. If you're doing something that's very much driven by events that happen in the network, by VMs, by whatever, right? We can use the state machine approach, right? Have a state machine. I'm going to push a VM to the network through ESC. I've got a state now that is basically waiting for ESC to come back. ESC sends the notification back. This is a new state transition to a new state, which is deployed day 0 config. There may be some licensing thing now that you have to go and do. So, the state transitions to waiting for licensing to be approved. Something triggers you now back to NSO, netconf event, or an SMMP trap or something that says, licensing is now done. The VNF is licensed. So all of those things are kind of where automatic things are expected to happen. Occasionally you might need a human to go kick something, but state-driven workflow, it kind of makes a lot of sense in NSO. The other way you can do it is a human-driven workflow in NSO. Long-running actions that are done by a human, like put a CPE in and plug it in, or go put a line card in and plug a cable in. Go move a cable from one port to another. Go add a new connection between a pair of devices. Right? Those things, it makes sense. If I've got an infrastructure service that's modeling a bundle of connections and someone goes and adds a new link between two devices and I want to bring that into the bundle, there's no real workflow, but if you want to put workflow in, okay, you just start writing actions. I have an action and it does some stuff and it invokes redeploy or it changes the config of the service. Okay, I've got a complex check operation. I want to check that CDP or LLDP is recognizing the correct neighbor at the other end of the link before I continue to the next stage of my provisioning. So I'll write that in an action. It goes, it runs some live status commands on the device, checks that the neighbor device is the correct device before pushing a next piece of config or hitting redeploy. And we use that with reactive fastmap. But I guess this is where we maybe kick off the discussion, because is this a pattern or is this an anti-pattern? Right? I'm not sure. I think you could argue that workflow is far better outside of NSO than inside when you're waiting for these long-running human actions where you're checking the operational state of things.
I'll jump in and comment there. Actually, I think that the thing that you describe here, and you call it workflow, inside an NSO environment, it is qualitatively different. It is not a workflow anymore. It is definitely different states. You have state A, B, C, and D maybe, and there's a sort of linear or maybe bifurcating flow, which says from A you want to go to B, and from B you want to go to C. So there's a direction, but in a workflow, in a traditional workflow, you focus a lot on these states and the transitions, every transition between one state to another and what needs to happen in every transition. Inside NSO, you don't do that. You only describe, okay, when I am in state B, I want to do these things because that will lead me to state C. But in actual real life, the state transition is not always A, B, C, D. It could be A, B, C, something happened, you're back to A again. But there's no code in the NSO service that describes how to go to C, from C to A, because NSO will compute all of that. So it is not a traditional workflow in any way. It's qualitatively different inside NSO. So I think it's kind of dangerous to call this a workflow. It has something to do with states.
Yeah.
But it's not a traditional state machine either. So it's state convergence is a term that we usually use. State convergence is trying to converge towards state D, but it's not workflow, it's not state machine.
Yeah. Yeah, and I think that highlights one of the things I probably should have put on here with that human-driven side of things is with a real workflow, most of your time is not spent on the happy path. Most of your time, if you work in workflow, is handling all the errors and exceptions, and writing actions in NSO to handle those is not ideal. Yeah, I did at the beginning. You remember I asked Jan about nano services. So they kind of put this state mechanism into NSO in quite a nice way. I haven't actually had time to play with that yet, which is why I didn't want to talk about it too much. But
right, but I think I have seen some good examples of nano services, but when I try to apply it, I found some issues too. I don't think that model is ready. It's a good idea, but it's not complete, in my personal opinion.
Yeah. Okay,
still called experimental, so if you want to try it, please, and let us know how that goes.
So that's almost it. So I think, Jan, timing-wise, what's happening now?
We can have a discussion for 10 minutes.
Okay. All right. I'm going to then just jump ahead quickly. So out of this, why did I do this? Well, I said at the beginning, I hate duplication of effort. When I came to NSO a couple of years ago, I wanted to see this, and it still doesn't really exist today. I'd like your help, that everyone in the room who's an active practitioner in this space, who's doing this, to kind of help. And this is, as a community, I think this will help elevate our practice. So I'm going to commit to putting a couple of examples on the NSO GitHub, build a couple of these out as example packages, and I'd like the broader community to help us expand on that and kind of have a discourse around what's a good pattern and what's a bad one. So back to the discussion.
So who has any comments on any of the patterns that we've seen so far? Or maybe another pattern that wasn't listed here? Maybe you should take them one by one then, if nobody volunteers.
Yeah.
Go back to one of these slides that you had on one pattern and see if somebody has comments on that.
All right. This one's one of my favorites.
Okay, how many of you are using stacked services? That's about half or so. Maybe that's as many as there are programmers in here. I don't know. And how do you find that? Is that something that works for you?
Stacked services in LSA. What's your comment?
Aha. I've lost the mouse. Never mind, I'll click through. Not these ones. Okay. Stacked services make sense. Shared responsibility, right? If you have a layer 3 VPN service and you've got two teams, one responsible for the Cloud Connect and another one responsible for like secure network, it makes sense to split the package, do stacked services, to specialized services. Shared responsibility, this is a classic example, vBranch function pack. Cisco's responsibility, we give you a nice full fat model. Everything is an option, but you as a customer might, you have a specific flavor of things, right? That's good. This potentially works very nicely with LSA. That's the phased apply. Organizational boundaries, and this I think LSA gets used a bit more here, where one team has one NSO, another team has another NSO. Team one's responsible for access services and internet. Team two is layer 3 VPN, and there's some overlap. So stacked services are kind of required almost for LSA. So I think it's the note, that one. Yeah, so obviously you need stacked services for LSA. And there's some of these ones I just quickly went over. There's a few different ways, there's some challenges with LSA, especially when you have these kind of border devices, who owns them. That's a fun discussion. So if you have both sides trying to talk to that device, you'll end up with those sync issues. So you could fix it in the network. Well, actually, I'm missing the slide there. But the other way is to pull the config of that device into the upper NSO. I don't know. There's a lot of ground to cover in service design and LSA. Yeah.
In case of shared services where two NSOs are responsible for. So in case of shared services where two NSOs is responsible for one package, how do you maintain, which database of these NSOs maintain the configurations?
Yeah, that's this challenge.
So yeah, who's the master of the inventory?
It's hidden. That's why it's not coming up. Hidden slide. Yeah, so we have this option, right? We push the control of that border router up to the top, or we just make a decision. A owns it or B owns it. So design decision, it's probably one you're going to want to make with the operational team in the network. Who owns it? Do they see it as a separate dedicated border device, or is it really owned by one of these two kind of domains? Was there a question down the back? Oh, yeah.
Yeah, it's a comment. So we had very good experience with stack service, and customer is loving it. So when we started on customer onboarding with a customer, they want flexibility. So we had to break the service into multiple services, and then we went into problems with atomic transactions. So we had to implement that in a kludge way. But once the stack services were available, then we implemented stack service, and now it's all payload driven, and even future services we can just drop in as microservice, and customer is loving it. So it's the way to go.
Yeah. I thought about putting something very similar to that in as a pattern. It's the end-to-end kind of pattern where the child services represent discrete, independent services, and you build an end-to-end service over the top. It's a useful one.
So with the LSA and stack services, what is the best design pattern to have the RFS nodes also have the similar model of CFS, or the CFS directly talks to individual RFS models? So in terms of performance and modularity.
Yeah, I'm not an expert in LSA.
Because we wanted to understand how it will work in terms of the LSA deployment. What is the best pattern?
Yeah, I think LSA is still a bit too new to say that there's one best pattern. I'd be very keen for some of my colleagues, some of our community, to put together their thoughts on nice patterns for LSA. The mechanics of LSA I think are very well understood, but some of the design considerations and what is a good stack service design for LSA, I'd say, is still area for exploration. Maybe we need to do the profiling, but I think it's more of a few people need to get some battle scars and come back and tell us all what works.
So any final comments on this topic? Very good. So thank you very much, Mark.
Thank you, everyone.